Now that is what a midterm is supposed to feel like. Just as a quick update, I took my citizenship and public ethics midterm yesterday, and it felt fantastic. I'm on top of the world right now. If you're confused, yes, it is Friday today. I only had math discussion yesterday and the midterm. Obviously, we didn't cover any new material on the midterm, so I skipped yesterday, and instead I am recording today on Friday, which gives me a good opportunity to go over some new material. Also, I've made up my mind there isn't going to be a video on Monday because that's President's Day, so it's a 3-day weekend. I'm probably going to spend the day studying with a friend for physics, which is next Thursday. I'm so excited for the physics midterm! Also, I have a statics midterm that is either this next Wednesday or the Monday after President's Day, which I'm not quite sure because the syllabus says that it's the Monday after President's Day, but I heard from a friend that it was on Wednesday. I obviously want to believe the syllabus more, but until I can get some confirmation, I'm going to be studying that over the weekend as well. But for now, let's do some calculus. Before I get started, let's pay a quick moment of silence to my green marker. It ran out during a review session. You'll be missed, my friend. So now let's do some calculus. We're going into a little bit more detail with multivariable functions now. We covered them with the equation of spheres and with quadric surfaces, but never as in-depth as we have now. Because now we're going to learn how to take limits of these things. We already know how to take limits of two-dimensional functions. We also know that if we approach the point in the limit from one direction, and we approach the point in the limit from another direction, and the limits that we get are not the same, that the limit does not exist. This is pretty easy to find out with two-dimensionals because there are only two directions that we can approach the limit from. But with multivariables, it gets infinitely trickier. Literally, there are an infinite amount of directions that you can approach the limit on. You can approach the limit along the x-axis, the y-axis, along the line y equals x cubed, along any line, even this monstrosity. If the path exists, you can approach the point along it. And that is what is so mind-bogglingly infuriating about these multivariable limits. Because even if you have 1,000 paths that you can take to get to the same point using the limit, if you have one path that doesn't get to that point, the limit does not exist. And right now, there's only one real way that I know how to do this. And it feels awful, because it is just glorified guessing and checking. We basically pick a path that we want to check the limit on, we find the limit along that path, and then keep doing that until A, we get tired, or B, we find a path where the limit is different than all the other paths. And from what I've done on the homework on this so far, they've only given me problems where the limit doesn't exist. Let's say, for the sake of example, that we want to find the limit as x, y approaches 0, 0 of this function right here. We need to start finding some limits. Let's go along the x-axis first. We don't even need to take the limit here because the function is going to equal 0 for every single point along the x-axis. Y is equal to 0, then the entire function is going to be equal to 0 every single time. Let's do the same thing with the y-axis. This time we actually get a function, so we need to take the limit. We're going to take the limit much in the same way that we take a single variable limit. Since the function is defined when y is equal to 0, we can just plug it in. We get that the limit as we approach the function both on the x-axis and the y-axis is 0. But there are more paths than just the x-axis and y-axis. And as it turns out, we don't need to do very much digging to find out that this limit overall doesn't exist. Okay, I've been getting a little flustered because it turns out that I'd done this problem on my homework incorrectly. Because as we can see here, that if we plug 0 in for x, we get the same answer. But there is something that you can plug in to make this limit not exist. Let's try replacing y with x minus 1. So this is going to be the pure unsimplified form of our function. If we do a little algebra, we get this at the end. The quantity of x minus 1 squared in the numerator and the denominator cancel out, and we're left with 1/2. This is different from the zeros that we were getting before, so the limit doesn't exist. What I am not so jazzed about is how many times I needed to try before I was able to get the right answer. And I don't even know what I would do if we had a limit that did exist. Luckily, lecture will be on Mondays, so I can probably ask a few questions there, and if that doesn't help, then I will ask questions in discussion on Tuesday. But I have a review session for physics that I need to be at in 15 minutes, so I'm gonna put a cut in here, and then I'll come back later tonight and do some review for statics.